Okay, in the previous videos, I've been trying to show you what the different laws of exponents are and why they're true. What we want to look at now is how do we actually use them in practice. So I'm going to look at this particular problem as an example. Suppose we want to transform this complicated weird thing into a single exponent. So I'm going to have to try and use some of these laws, some of the rules of exponents, but right off the bat, none of them is really well set up because we have different bases. And most of our formulas have always the same base, a. And the other rules have the same exponent everywhere, which we don't have either. We have 3, 5, and 2 as our exponents. These bottom rules have all the same exponent if you do have different bases. So we have to be a little creative, but there is actually a hint hidden in the problem, which is if you look at the bases, 2, 4, and 8, they have something in common. Namely, they're all powers of 2. So maybe I should use that somehow and rewrite everything as a power of 2. So I'll go left to right. I'll rewrite each of the bases as a power of 2. So 2 is already a power of 2, I don't need to mess with it. 4 is 2 squared. 8 is 2 cubed. And then all of a sudden this does look like one of the formulas we've seen before might exactly apply. Just be a little careful though. If you look at this top rule, we have an exponent times an exponent, but this is not quite an exponent times an exponent. There's also another power in there. So I should first maybe rewrite this as a single power. So I should maybe see if I can simplify that and that, which shouldn't be complicated because we have a rule for it. Mainly this right here. If we have a power, we're supposed to multiply the two exponents. So that'll be my next step. We're going to multiply 2 and 5. We're going to multiply 3 and 2. Let's see, 2 times 5 would be 10. And 3 times 2 would be 6. Okay. I'm going to try and figure out what my numerator is next. We have an exponent times an exponent. That is exactly what this says. And a power times a power, you're supposed to add the two exponents together. So let's continue on the next line. 2 cubed times 2 to the 10th, we're supposed to add the 3 and the 10, which means we're going to get a power of 13. And then again, what we have here is a power divided by a power with the same base. And so we look and see, do we have a power divided by a power with the same base? Yes, we do, right here. And so what we're supposed to do is subtract the two powers. So 13 minus 6 would be 7. And so our answer would be 2 to the 7th. It says rewrite as a single exponent. That's it as a single exponent. Okay, you might want to pause. I'm going to have to erase to give myself some room. And then we'll try another example. Same instructions, trying to rewrite a complicated expression as a single exponent. Okay, the one I would like to try is 6 to the power of 5 times 2 to the minus 3 divided by 6 squared. Okay, this is another complicated one. This is actually a little bit trickier than the other one. The other one had at least a hint. Everything's a power of 2. That's not the case here. We have 6's and 2's. 6 is not a power of 2. So what I think I'm going to do is maybe put the 6's together and cross my fingers and hope something magical happens. Okay, so let's rewrite this as 6 to the 5 divided by 6 squared multiplied by 2 to the minus 3. So just to make sure we're not cheating here, anything that's multiplied should be in the numerator. Anything that's divided should be in the denominator. If you wanted to, you could rewrite this guy as 2 to the minus 3 divided by 1. I don't think it's really necessary. I'm just going to leave it like that. Okay, so now again you should have some ideas of how we can proceed from here. 6 to the 5 divided by 6 squared looks an awful lot like this rule, where we're going to be subtracting the two powers. So if I rewrite the left side, 6 to the 5 minus 2, 5 minus 2 would be 3. And 2 to the negative third power, I can do something with that also. We have a negative exponent here. A negative exponent moves you to the denominator. So this would be 1 divided by 2 cubed. And so let me combine it to be a single fraction, because I think I have an idea of where we're going next. 6 cubed divided by 2 cubed, even though they don't have the same base, they do have the same exponent. And so we have a rule that has the same exponent. The very bottom rule. So I guess A is 6 and B is 2 and N is 3. So 6 divided by 2 raised to the power 3. So that's something to be aware of, is sometimes we're going to be using these formulas kind of backwards, working from the right to the left instead of the left to the right. Totally okay. We'll be using them different ways for different problems. Now we have 6 divided by 2 inside the parentheses. I can rewrite 6 divided by 2. That's going to be a 3. And so a lot of times it is just going to be creativity. Can we come up with a way to creatively use this list of formulas? So if you're working on homework, I'd say go ahead and have the list of formulas available to you. Practice using them. That's fine. Long term, by the time we get to a test, probably we'll need to have memorized all these laws of exponents. But for now, if you want to, have a sheet of paper next to you while you're working on your homework that has the list of formulas, I think that is a great idea for now.